Hello guys and welcome back. Today we'll be talking something related to SI engine. We all know that a basic spark ignition engine works on OTTO cycle. So there are four strokes as we all know. Let us simply go through all these strokes. So here this is the intake, the compression stroke, the power stroke and the exhaust stroke. And now when the spark ignition takes place when the piston is at about the top dead center. So when the piston is at the top dead center, the spark takes place and it combusts the charge, that is the mixture of the fuel and air. So now my question is, what if we change the timing of the spark that is taking place? Or in other words, if the spark ignition takes place before or after the optimum time, what can be the effect on this engine, and how will it affect the efficiency of the engine? Let us understand this with a simple PV diagram of an OTTO cycle. Here I have shown the basic PV diagram of an OTTO cycle. Here the charge first enters the combustion chamber. I have not shown over here, but it's, let's say it's 0 to 1. The path 0 to 1 defines the entering of charge in the cylinder. From path 1 to 2, the piston is traveling from bottom dead center to top dead center, like I've shown over here. The charge gets, whatever the charge in there is present over here gets compressed, hence the pressure is increased. At this point now, the spark ignition takes place. So the pressure is increased at the constant volume. Then the power stroke and the exhaust stroke, which releases the exhaust gases. Now, what would happen? What would be the change in this if we delay the ignition timing? A piston is traveling from 1 to 2. It has compressed its charge, which is present in the combustion chamber. But now there is no spark ignition that is taking place. So hence there will be no increase in pressure. The piston will travel back through the same path. That is, from the piston will start traveling from the top dead center to the bottom dead center. But now in between we are applying the spark ignition, so the pressure will increase because of the added heat, and the power stroke, this will be the power stroke again and the exhaust stroke. So this is the new path that we achieved with the ignition delay. You can clearly see that the work done by this process, the process with the ignition delay, is quite less than the original work, the original cycle. The difference over here is like I've shown here with the shaded area. This is the difference, and hence if the work done is less, then the efficiency will also be less. The overall efficiency will also be less. When the piston is traveling back, when we are when we are adding the heat to the system over here, at that moment, this is the new volume that we get. So, like I have shown over here, this R factor is basically the ratio of the maximum volume and the minimum volume. There will be increase in the minimum volume as compared to the earlier cycle. Hence, the value of R will be decreased. This ratio will be increased, and you can quite understand that the overall efficiency will be decreased. To cut things short, to keep it short, let me just clear it that if we have an ignition delay, the overall work done will be less, hence efficiency will be less. What if it's the other way around? What if we are giving, uh, what if there is an advancement in the ignition timing? Advanced ignition, as we can say, the path will be the same, but instead of reaching completely till top dead center, the piston will be, like, say the piston is traveling from bottom dead center to top dead center, and before it reaches the top dead center, we are applying the heat and the same path will be followed. So what do we learn from this? If doesn't matter if we provide an ignition delay or advanced ignition, the work will be the work done will be less and the efficiency will be less if the ignition does not take at the optimum timing. So next time, if you want to modify your vehicle, if you want to tune your engine, and if you change the ignition timing, we would want to know this, that you are basically decreasing the efficiency of your engine. So this was all for the video. If you have any doubt, if somewhere something you did not understand, you can feel free to leave it below in the comments section, and I'll see you guys in the next week.